now we're learning something really relevant to, again, 20-1 and 30-1, and it's called function notation. Okay? Now, this is a whole new thing for pretty well all of you, because you've always been doing like y equals 2x plus 3. Okay, that's what you've always seen. But we're going to take that y, and instead of calling it y equals, we're going to call it f of x equals 2x plus 3. So f of x actually stands for y, but what it means is this is the function x equals 2x plus 3. So if I put f of 5, it's like this thing's like a sausage machine, right? And they're like, well, if you put x in, you get 2x plus 3. If you put a 5 in here, f of 5, it means, what does this thing equal when I put 5 in it? And then you'll go 2 times 5 plus 3. Oh, that's 13. So you'd say f of 5. So you'd see f of 5 equals 2 times 5 plus 3. F of 5 equals 2 times 10 is 13. So it says when you put 5 into this function, you will get the output, or the y value, of 13. Okay? So it's a little weird at first. I remember when I first learned it, it's like what? So I put the x on that side too? See, this doesn't mean I'm actually substituting x into this side. It means I want to find what this function equals when I put x in it. So then, or 5 in it. So I will put 5 in the entire function to see what I get. So this is, remember that mathematics, probably the most complicated thing about math is how efficient it is. Okay? Because this entire thing has a meaning. It's saying, hey, when you take this function and put 5 in it, you get the answer 13. That's what f of x equals 13 means. When I just have it as y equals 2x plus, right, then I'd have to say, well, make x 5. And then you'd put x here and you'd get out a, but why don't we just say right here, what's this function when x equals 5? Yes, Shanna. You can't do it. No. No, function notation only deals with x and y. Yeah? Yes. The function and then the x is the function when I put this thing in it, which actually gives you the y. So f of x is like a synonym for y. Okay, they both mean the same thing. So they do, they are interchangeable, except this gives me so much more information. Like when I read this sentence, like if you just said, you gave me, hey, y equals 13, I'd have to ask, well, like what did you put in for x? This tells me exactly what you put in for x. So it is a more efficient way, but it gives you all the information you need. Now we can also not just put it into mathematical equations, we can actually put it into just pictures. Now this first example just has a graph. And it says, well, what is the function? Because remember f of x. What is the function when x equals 2? This is what this means. What is the function? Or I'll say, what is the answer to this function? Okay, can you guys put your candy and stuff away? Because it's a distraction for people, okay? Or else go outside and eat. I'm good with that. What is the answer to this function when x equals 2? This means exactly what I wrote down. Do you see how efficient math is? They just put f of 2. And it means all of those words. What is the answer to this function when x equals 2? Okay? F of 2 means that entire sentence. Okay, and we don't, I know you guys, if I had to write that out every time, you'd be like, is there like a quicker way to do this? Yeah, you could write f of 2. Sometimes when we get the efficient way given to us, we're like, oh, this is so confusing. Why do we have to know this, right? Well, people got sick and tired of writing this out every single time. So they're like, hey, why don't we just do f of 2? And we'll say that is, what is the answer to this function when x equals 2? So when x equals 2, so we go here. What does the function equal? I would say, so what is the y value when x equals 2? It's 5. That's the answer to this function. The answer is your y. So what is the answer? Let's put a little circle around that. This equals y value. Okay, I want you just to try all the other ones. And the last one, think about it. Okay? Okay, just try it. And we'll, I don't care if you make a mistake. That's why we have pencils. Yep. Yeah, this stuff is not hard. It's just impossible if you don't know the translation. Okay, if you ever go to another country that you do not know any of the language, the simplest things are so much work. Okay, just getting there and asking, like, where's the bus? It's like people look at you like you're an alien, right? And you might get lucky and they may know a little of your language, so you'll be able to pull it off. But if you've ever had the privilege of going someplace where you do not know the language at all, you really start to see the inefficiency of it. And you pick up the language quick. And that is why if you ever want to learn a language well, you have to inundate yourself with it. Okay, you have to get there, and out of sheer survival, you will pick up, especially bathroom, right? You'll get that one down pretty fast, trust me, okay? Well, yes, but I'm just saying our word, you'll get, because if they said water closet, you'd be good with that. Yeah, I got that one. I know what you mean. Okay, now, let's just go through this. So the next one says, hey, what does y equal when x equals -3? What are we getting, Raven? It's got to be positive, guaranteed. And like here's -3. If I was to follow that up, I would say 9. No, it's 9. Yeah, 9 or 10. Okay, trust me. Oh. Yep. Yep. Okay, so you find -3. What is the y value on the graph when x equals -3? So you follow it up till you actually hit the graph, and it would be at 10. And like Zach was saying, we're going to do it with the equation in a second. Okay, so how about f of 0? So 0, you follow it up, and you should get 1. Now, this one, can anybody translate for me what that is saying, or like, what is it asking, or like, what would you? What is x when y equals 5? Okay, that would be a perfect translation. So you find 5, right, which would be like about here. Okay. Oops, that's 6 1 2. Okay, so what is your answer? 2. Or, yeah, very good. Okay, if you come, see there's two answers. 2 and negative 2. Now, is 2 comma 5 negative 2 comma 5, is that a function? Yep, because we don't have one x with two different y's. We have different x's with the same y. Okay? That's like if you went to a vending machine and there was 10 things that were all the same price. Like, that's cool. Right? In fact, it's usually like that. Right? So, it's okay. Right? But if you had the same thing and they all had different prices, okay? The first question, or the first thing you would say is you'd start making excuses for that vending machine. Oh, the guy probably put them in the wrong things. You know, you would know that it's not a function. Okay? Now, as Zach was saying, this is the equation of actually that graph. Now, do you have to know that? No, you don't. But, and it says, well, what is f of 2 algebraically? So we say f of 2 equals 2 squared plus 1. F of 2 equals 5. So by looking at this, this says to me, just like we said before, the answer to this function, if you put in for when x is 2, equals the y value of 5. Okay? Okay, spend a minute per graph and answer those for me. Okay. So for the first one, when x is 1, what does the function equal? 0. Okay, what would I have to, what x value would give me the answer 3? Negative 3, right? So here's the 3, and I come down, I find the x value of negative 3. Okay, on the next one, when I put in 1, it will give me the answer 4. When I put in blank, it gives me the answer 1.5. Okay, whoa, 5. See, here's 1.5, you guys, right here. Right? So I'm saying f of 0 would equal 1.5. Okay, you can't get your y's and x's mixed up. What's up?
Can you say f of something if it's not a function?
Yep. Yeah, that's a good point. Yeah, function notation is actually different than a function. Yeah, function notation you can use for non-functions. We're going to do some of those on the next page. That's a good point. So they actually are same words used in different contexts. So a function is very different than function notation. Excellent question. Okay, next one. F of 1 would give me negative 1.5. What x value gives me negative 1? Okay, so negative 1 is here, correct? So I'd say about 0.5. Okay, so on to Sarah's question. We're going to do function notation for 4 and 5. Are 4 and 5 functions? No. Okay, so you can use function notation for non-functions. Okay, so f of 2 would equal, and we can say that as plus or minus 2 because it gives me here and here. So this is not a function, but yet we're using function notation. The irony. It's thick. It's thick on this one. Now, what x value gives me the y value, negative 1? Yeah, I would say negative 1, right? Just negative 1. What else gives me a value of negative 1? This is the only negative 1 on here, correct? It's not a function at that point, but, right? What value, what x gives me negative 1? And it is negative 1. Yeah, well, you got to answer the question, right? It's there's no other actually question I think that would make sense. Okay, f of 4. Negative 1 and 5. Okay, so here's your 4, right? And you're going to go up to there, and you're going to come down here. So negative 1 comma 5. Huh? No? You take x is 4, and you find the y values when x is 4. This says find the y value when x is 4. This says find the x value when y is 1. Okay, what would you say? Five and negative 5. So there's my two places where y equals 1. So f of 5 equals 1 and f of negative 5 equals 1. Okay, you're starting to picture the quiz tomorrow. Okay, easy to ask this kind of question, right? You got to have all of your bearings to be able to do this one. F of 1 equals 3. F of what equals negative 1? Negative 3. Okay. So we're going to do function notation on these equations. So f of 2, now here's the equation, f of x. And often you'll just be given the equation, and then they're going to say, hey, plug this in, plug that in, okay? So f of 2 is same thing as 2. Do you see how there's an x here, here, and here. If I take x and I replace it with 2 on here, I'm going to do the same thing on the other side. But always, always, always do it in brackets. Okay? See, wherever there was an x, I put a 2. So now this function I have set up. So what is f of 2 means what is the answer when I put 2 in? That's like 2 times 4 plus, or not plus, minus 3, right? Because positive 2 and negative 5 is negative 3. F of 2 equals 8 minus 3. F of 2 equals 5. So this function equals 5. So I used to do something like this. When I taught junior highs, I would go like this. So here's, if I put in x, I get an answer, which would be y, correct? So if I put in, say, 1, I get the answer 4. Okay? So instead of calling this y, I'm going to call this f of x. See, that's the answer when I put in x. So f of 1 equals 4. F of 2 equals 11. And f of 3 equals 21. What is my function? Okay, what would the function be? So it's like a little machine. I'm putting in 1, it's spitting out a 4. I put in a 2, it spit out 11. I put a 3, it spit out 21. What would be my function? Raven, you want to try it? No, there's not a trick. You got to try. Like, what can you do to 3 to get 21? Yeah, but it's got to work for all. The same rule has to work for all of them. Like, if I put in 0, I'll put that one in too. If I put in 0, I get out 3. Yep. Yes. Yeah. Oh, sorry. This is 5. My mistake. Okay. Well, now you know. Try it. It is. The function is 2x, oops, plus 3. See, if you put in 0, you get 3. If you put in, oops, 2x squared plus 3. If you put 1, right, you get 5. If you put 2, you get 11. Okay? So, and I would do this with grade 7s all the time, right? Yeah, it would be 2x squared, right? Because if I put in 0 squared, that's 0 times 2 is 0, I get 3. If I put 1 squared is 1, 1 times 2 is 2, plus 3 is 5, right? So this is called the function, right? The machine, the thing that I'm putting it into, this is input, and this is output. And there's not one you could do that a class couldn't get, right? I mean, you could get ridiculous, I guess, right? But like, yeah, I could do grade 12 level. Just put in this, get out this. Put it in, a class could always get them, right? If they could work through them enough. And again, it's just getting the before and after. Like, what happened in the middle, right? And you know, it's excellent way to be able to train your brain. Like, if you look at anybody that has to deal with any sort of forensics or They come across, like a car accident, they come across a crime scene. The entire process is mathematical. What happened here? And they gather things. They gather inputs, they gather outputs, and they figure out the middle. Okay? That's their job, figuring out the middle. Okay? They come across an accident. They know what happened. They got that all under control. Okay? They'll figure out what it was before it happened. They got that under control. Those two are easy. Okay? It's figuring out the stuff in the middle that they pay you big money for. Okay? And if you do it well, you get paid very well for that. So that's all this is. It's just mathematical reasoning, figuring out what happened. I know before. I know what 1 got put in. I know a 5 came. What happened in the middle? Okay, 2x plus 3 happened. Okay, f of 0. So again, that's 2 times 0 squared plus 0 minus 5. And f of 0 is minus 5. Okay, this is the one, a big one, that if students do not use brackets, they get it wrong. So f of negative 3 equals 2 times negative 3 squared plus negative 3 minus 5. F of negative 3 equals 2 times, what does this equal? 9. If you don't put brackets, you get the answer negative 9 in your calculator, and then, of course, everything's bad after that. And then, what's negative 3 and negative 5? Negative 8. So then we've got 2 times 9 is 18. 18 and negative 8. F of negative 3 equals 10. Okay, we don't need to do D. Let's do E, because E's like taking it to a whole other level. Like, I can put anything in there now. E and F, I don't have to just put a number in there. I can just put an equation inside your equation, which is called a compound function. So if I put 2a into this function, f of 2a equals 2 times 2a squared plus 2a minus 5. Okay, so you got to really keep things straight here. It's a good thing we did a whole unit on exponents. It's a good thing we did a whole unit on multiplying, combining like terms. Okay, we have spent a lot of time up to now. We have done 4 units. Well, 2 really important units to get you here. Trig, not going to help you here. Measurement's not going to help you here, but the last 2 units will. Now, f of 2a equals 2 times. Now, if I brought that 2 in, what would be inside here? 4a squared. Right, because 2 squared is 4, and then plus 2a minus 5. What would this equal? 2 times 4a squared. 8a squared plus 2a minus 5. Okay, and that's the best we're going to get. Now, we could probably even try factoring that, but we won't. That would be a complex factor, right? What plus what equals negative 2? What times what equals negative 40? Good times. Happy memories. Okay? Okay. Now, this one here, not for the weak. Some of you guys might even cry doing this one. This one's 2 times 3y minus 1. Oops. Squared plus 3y minus 1 minus 5. Okay, so now this is the same thing as 2 times 3y minus 1 times 3y minus 1 plus 3y minus 1 minus 5. Okay, see, I didn't go 3y squared minus 1 squared because we know we can't do that. You need to FOIL. So this equals 2. Now what's going inside is 9y squared minus 3y minus 3y plus 1. We've got to multiply. Plus 3y minus 1 minus 5. Okay, equals 2 times 9y squared. What's this? Minus 6y plus 1 plus 3y. Now we could actually just get rid of my brackets here. This would be 3y. What would this equal? Minus 6. Okay, what do we have to do next? We have to go and put in the 2 to everybody. Equals 18y squared minus 12y plus 2 plus 3y minus 6. What's next? Like terms, we've got this one and this one, which would give me minus 9y. And then I've got the two numbers here. Hold on here. Yep. Okay. Everyone see how we got from A to B there? Okay, so we're going to do one more example. And it's not the one in your book. Because so we're not even going to do that above example. So this example 3, if f of x equals 2 x minus 3 plus 5, determine x at f of x equals 12. Okay, so what does this mean? Now here, do you see that f of x equals 12? So what does this equal? 12. It says f of x equals 12. So put a 12 there, because they're equal. And then you just go to x minus 3 plus 5. Okay. Now what do we have to do? We got to get x by itself. So how do we do that? Yep. We are going to subtract 5 first. Right? It's bed mass backwards. Okay? You always do bed mass backwards for when you're doing algebra. So 12 minus 5 is 7 equals 2 bracket x minus 3. Then what should we do? Divide by 2. Okay, and we'll change this one to decimal. We got 3.5 equals x minus 3. Then what? Add 3, and you'll get 6.5 equals x. So the statement that you would write is f of 6.5 equals 12. That's saying, hey, this function, when you put 6.5 into it, gives you the answer 12. Gives you the y value of 12. Okay, here's what we're working on. We've got lots of time. Please be checking your answers so you are not doing it wrong.